Hi, I'm Tom from AWS, and today I'm joined by James from Zappos. Welcome, James.
Hi, Tom.
So tell us, what does Zappos do?
Zappos is a service company that happens to sell blank, and I think we're most well known for our customer service as well as the shoe selection that we sell online.
Everybody loves Zappos.
Absolutely.
Yeah. So what's your role at Zappos?
I'm a lead software engineer, and I'm over the back office systems team.
Okay. And so we're going to talk about some of your back office stuff here today. What are we looking at?
So what we're looking at is a simplified version of one of the architectures that we help support. We pretty much have a front end and a back end. And if you don't mind, I'll kind of jump in.
Let's jump into it.
Okay, so one of the original problems that we were trying to solve was the fact that we had an inconsistency between our production deploys as well as our development.
Okay.
And because of that, that was creating support issues and everything else. So when I joined the team, I was like, we need to fix this. So what we did was to help make those consistent, we introduced Docker. Then the Docker was then we're able to do the consistent deploy between the environments, and then that reduced support, gave better customer experience to our internal customers, and we went from there. So.
Nice. And I guess that's why you're using ECS.
Exactly.
Yeah.
So then when we did the migration to AWS, ECS was a natural fit for that.
Fantastic. So walk us through the data flow here. Where do we start?
Sure. So we have a human readable DNS, which is provided to us from Route 53. Yeah. So then from there, that goes in. It goes to a application load balancer, and that then goes to our Elastic Container Services, which we have 2 instances running here as dedicated, but it's also set up to scale, so if we need to get up to N, then we can get the...
So you get the scalability.
Exactly. Yep. And then from there, the front end then calls the back end, which goes back to our Route 53, which then goes to our back end's application load balancer, which then goes to another ECS, which again has 2 dedicated instances and then can scale as needed.
Right, so same pattern on the front end and the back end?
Correct. And then the back end has a connection to Aurora MySQL. And then also part of its processes, it actually generates messages and consumes messages from a Amazon MQ setup.
Amazon MQ. So tell us about the choice of using Amazon MQ.
Sure. So part of this was a slightly older code base, and we had an older version of ActiveMQ that we were using, and we had several instances where we had production issues. So when we were doing the migration to AWS, we're like, hey, can we actually do a replacement?
Right.
And part of the reason why we actually chose Amazon MQ is because the protocol is pretty much like a one-to-one with ActiveMQ.
So it like just allowed you to take those applications that you already had and plug them right into Amazon MQ.
Exactly.
So you've got a cool scalable architecture here, and you're pushing that data into Aurora MySQL. But did you start with Aurora when you started that migration?
No, we actually started off of a Oracle database, and then part of a directive from above was that we needed to get off of Oracle. So we looked at Aurora Postgres originally, because the syntax between...
That would make a lot of sense.
But the syntax is very similar, but our team was also supporting a bunch of other databases that were similar to MySQL, and the team had more experience, so they could do better performance engineering utilizing MySQL.
Got it.
So,
got it. So what did that take? How did you go from Oracle, this proprietary database, over to MySQL?
Sure. So what we did was we actually utilized DMS, and we actually did a data dump into a database so that we actually could do some like performance testing to make sure that, well, 2 things. One, when we did the query translation for the variances in the syntax and like functions that may not exist, that we were actually getting the same results. And then after that, we then looked at the timing of the queries and made sure that they were like within a standard within a standard deviation. And if they weren't, then we did performance engineering where we added additional indexes, compound indexes, and we even did some setups where we would actually do a query, write it to like a temporary table for like the equivalent of like an MView, so that we could then query against that. And then like in that particular, like I remember one instance where we improved a query from 15 seconds down to 50 milliseconds.
Say that again.
We had a query that we reduced the time from 15 seconds to 50 milliseconds because once we wrote it, it just made it that much easier to query.
That's incredible.
Yeah.
So the use of the database or migration service,
Yes.
it sounds like it really helped you.
Yes, it was pretty much the foundation for the migration,
Yeah.
and then after that, it boiled down to a lot of performance engineering after that.
That's great. And how's it working for you now?
Oh, fantastic. So
Yeah.
it's running fast, reliable, scalable. We have it set up so we have like a read-write endpoints that we're utilizing, and the readers can actually scale. So like if we hit a big performance for a relational database, we still have a way to actually scale with that.
Interesting. So you've got one instance that you're writing to, and then a whole bunch of read instances for throughput.
Yes. So it's a one writer, one reader. However, we can
You can
add
scale
additional.
the readers.
Yeah. So we can scale horizontally instead of having to do it vertically for the relational.
Awesome.
Yeah.
Well, this is really cool architecture. You've solved some really big problems in creative ways. Thank you for sharing your architecture with us today. And thank you for watching. This is my architecture.